Hello friends. So this video is going to give you a little refresher course in using spreadsheets and walk you through the calculations for part 1 of the Thermodynamics of Solubility lab. So our ultimate goal is to calculate the delta G for every trial that was conducted. So we have a spreadsheet put together with all 86 trials that were completed. And we're going to be essentially doing the same calculations for all of these trials and then creating a graph of the results. So that sounds like a lot, but the wonders of spreadsheets are that we can do the math once and then copy and paste. So let's take a look at what we need to do. First thing we need to do is calculate the molarity of each solution. So we know that molarity is moles of solute divided by liters of solution. So we need those two pieces of information, and then we need to do moles divided by liters to get us the molarity. So we don't currently have moles or liters, but we have grams of solute, which we can convert to moles, and we have milliliters of solution, which we can convert to liters. So those are the first two things that we're going to do. So our mass of solute is over here in column A. So to calculate moles from mass, we know that we just need to divide by the molar mass. So when you're using a spreadsheet, in order to tell the spreadsheet that it is going to do math for you, you start with an equal sign as the first thing that you type into your cell. So what we want to do is tell it to take the mass of the sample and divide it by the molar mass. The mass is 7.1 for this trial, but we don't want to type in 7.1. We want to tell a spreadsheet where to go find that information, and that is in column A, cell 2. And you'll notice that it highlights this cell. So it's going to take the value from that cell. It's showing us here that that is 7.1, and we're going to divide that by the molar mass of KNO3, which is 101.11. So when you're typing into a spreadsheet, you can type in math pretty much the same way that you would into your calculator. The only difference is that sometimes you're going to reference a cell instead of typing in the number directly. So we can hit enter. I am not going to use the autofills, and I'm going to strongly recommend that you not use the autofills either until you're really comfortable using a spreadsheet. Learn how to use it the normal way before you let it do a lot of the work for you. So we've got moles of KNO3. From next thing we need to calculate is the total volume of the solution in liters. We've got milliliters over here. So once again, we are going to start with an equal sign and tell it where to go find the number that we want, which is in column B, cell 2, and we are going to divide that now by 1,000. Note that it's making a suggestion here that's not what we want. So sometimes the suggestions are not that great. It thinks it knows what we want, but it is wrong. We're going to divide this by 1,000 to convert milliliters to liters, which we will need going forward. So from here, the next thing we can do is to calculate our molarity. So we know that molarity is moles divided by liters. We now have those two values calculated in these cells over here. So this is just going to be my moles divided by my liters, and that gets me my molarity. So that was step 1 of our calculations, was to calculate the molarity of the solution. For now, I'm just doing the first trial, and then I'll show you how to copy and paste for all of the other ones. So the next thing we want to do is calculate KSP at each temperature. So this reaction that we're dealing with is the dissolving process for potassium nitrate. So that is the potassium nitrate solid becoming potassium ions and nitrate ions. So the equilibrium expression for that is just the potassium concentration times the nitrate concentration. And if we find an ice table for this process, we find that these two things will have equal concentrations. And what is true in this experiment, what makes this experiment work, is that the temperature you recorded was when the first crystals appeared, which is when the solution is saturated, which is when you have this maximum concentration, is what this molarity is representing, your equilibrium molarity for a solution. So when the first crystals appear, your potassium nitrate concentration is equal to the solubility of that substance. And the solubility is equal to both the potassium concentration and the nitrate concentration. So if we're plugging that in to our equilibrium expression, we find that Ksp for this substance is just equal to the solubility squared. And the solubility is this concentration that we just calculated. So Ksp is just going to be that number squared. So again, we tell the cell where to find that, and we square it just like we would in our calculator. Use the little caret over the 6 on your keyboard to raise it to the second power. And then delta G is the last thing to calculate. So this is a new equation that we'll talk about a little bit in the next unit. But it is true that delta G can be calculated from K, from the equilibrium constant, using the relationship that delta G is equal to minus RT ln K. So R is your ideal gas constant. If we're taking this in units of joules per mole Kelvin, the value is 8.314. That is in your equation sheet for the course. And then T is the temperature in Kelvin. So that is another thing that we're going to need to calculate. So our crystallization temperature, we're going to need in Kelvin in order to calculate delta G. We've got it in degrees Celsius over here. So converting to Kelvin, we just add 273. So we can calculate that pretty easily. So then our delta G is going to be negative, R has a value of 8.314. The temperature is what we just calculated in column F. We want the temperature in Kelvin. And then we're going to take the natural log of K, which we calculated in column H. So that gets us the value of delta G for this process. So we've done this for one trial. We need to do this for all 86 trials, but we've done all of the work, essentially. So when you highlight a cell, you will notice that there's this little box in the bottom right-hand corner. So if you click on that and drag it, it's copying the same formula down. But notice that the value isn't always the same because it's not referencing the number 7.1, it's referencing the cell A2. And as we move down, it knows that you now want it to reference the next row. So when we get down here and it's referencing A9, and that's a different mass now. So that's why that changes. So we can click and drag this all the way down the column to the bottom, and you've now converted all of your masses to moles. But we can do even more efficiently, rather than doing each column independently, if you select an entire row, so I could have done this including the moles, but I figure I'll show you both options. If you select this entire row and do the same thing, it's now copying all of those formulas down at once. So we can click and drag this the rest of the way down the sheet. And you've just done the calculations part of this. So the last thing we need to do for part 1 is to graph this to actually get the delta H and the delta S, which is what we're really looking for here. So we are going to insert a chart is what we're looking for. Specifically, we want a scatter plot. Scatter chart it shows. Excellent. So on the x-axis, we want temperature. I'm going to move this out of the way. Move this over here somewhere. So where it says add x-axis, if you click on that and click on this little waffle, that is going to allow you to select a range. So we want the temperature in Kelvin to be on the x-axis, so we can select that portion of the column. And then where it says series, we can remove, we don't want the mass, but what we do want is the delta G. So again, it's going to let us select the range. Delta G was in this column, and we can drag that down. and hit OK. And that should, this is interesting, but that should give us the graph we're looking for. And you will notice that our data does all more or less lie along a straight line. What is this point? This is probably a typo of someone putting in their data. I didn't look that closely. Anyhow, what we need to do here is if you click on one of the dots in your, come here, on one of the, what are we doing? Apologies. If we click on one of the dots, or right click, that'll do it. Can't see behind my recording stuff. If we, where did my menu go? Sorry, menu, back, cool. Scroll down to your chart editor here and find trend line. If you select that, linear should be the default. And then for label, select use equation. And then the slope of our line is negative delta S. So our delta S from this is going to be positive 92.8 joules per mole Kelvin. And our delta H is the y-intercept. So that's going to be 20,614 joules per mole. So we're pulling these values from the y-intercept and the slope. So the way that that works is really just coming from this relationship that delta G is equal to delta H minus T delta S. If we just think about that in a slightly different way, we've put delta G on the y-axis and T on the x-axis. That makes negative delta S my slope and delta H my y-intercept. So by finding the line of best fit for all of our data, we're able to pull these two pieces of information out of our data for this reaction. So what was I gonna say? The calculations for part 2 are much simpler, but you should be able to apply these same ideas of just like how spreadsheets work to, excuse me, to calculating what you need there. So the only thing that's a little bit different in part 2, note parts 1 and 2 are in the same sheet down here, is that you're gonna have to calculate an average at the end. So to do that, you can just tell the spreadsheet to use the average function. Spreadsheets have lots of functions built right into them. So if you type equals average and then open parentheses and then select the range that you want to take the average of, so it's going to end up being these cells, close parentheses and hit enter. Right now it's giving me an error because there's nothing in here. But when there are values in all of these cells, that will automatically take the average for you. So that's the one piece as far as like spreadsheet functioning wise that is a little bit different for part 2, but otherwise it's just very basic math. Once you've done it for one trial, copy and paste it down for the rest, and then the last step is just taking that average. So hopefully that is helpful.